Hello everyone, Zeta Factor is back. Today we will be looking into parametric method of solving Diophantine equations. And we will be working on this interesting problem from, again, my favorite book. So what is parametric method? Parametric method is something where we try to replace our unknown variables like x, y, and z, and in case of Diophantine equations, those would be integers, with some combination a that to satisfy the equation that we are solving. I will show here one technique that can work for such equations like this. Prove that the equation x squared equals y cubed plus z power of 5 has infinitely many solutions in positive integers. To do this, what we are actually trying to do here is to look into this expression y cubed plus z5, and we will try to parametrize both y and z in such a way that when we sum them up, we will get like one holistic expression that can be represented as a power of 2. So what I mean by here is we will parametrize with this approach. We will parametrize y as like n, and here we will use same powers as we use as a here. So it would be parameter n cubed plus z5. I don't know which power that should be. Let's put it power b, and c we will put n cubed plus m5 c, and then x would be n cubed plus m5 in power of a. So you can see like what I'm trying to do here is basically I'm trying to find such numbers b and c, so when I add those in appropriate powers, such as this, I will get n cubed plus m5 power of 3b plus m5 n cubed plus m5 power of 5c, and this is equals, so like, and now we need to find b and c such as 3b equals 5c, and then we will be able to move these pieces outside, right? And then after we will move them, those pieces outside, m5, let's say we'll pick 3b because 3b is equals 5c, we'll get n cubed plus m5. So, and this would be equals, of course, x squared would be n cubed plus m power of 5 to a. So then 3b plus 1 equals 2a. So here's like where we need to find a couple of solutions of satisfying these equations. So, well, we don't need like fully solve those. We can just like find a couple of solutions here. So let's say b equals 5, c equals 3 works. In this case, a would be 8. A would be 8. All right. So in this case, if we will put x as n cubed plus m5 power of 8, y n cubed plus m5 number of 5, z equals n cubed plus m5 power of 3, this will give us the desired solution. This is the root of the parametric method of solving Diophantine equations. And just to recap what we did, we tried to emulate the same expression with a plus by parametrizing through m and n in a way that when we sum them up, we will get the same n cubed plus m power of 5, which will just add 1 to this expression, and we would be able to find the parameters in such a way that to solve this Diophantine equation. Thank you for tuning in to Zeta Factor today.